Welcome back, ladies and gentlemen. So I just had a conversation with the in-class, and they were like, oh, it feels like it's chemistry class. And I was like, yeah, good. But do you understand that we've almost just solved a huge problem in mathematics? So again, what we have here, let's flip over. This is so exciting. What we have here, one more time, we have a tree. We have an apple. But you have to understand what's really going here. We allowed it to fall for 1 second. That fell a distance of 16 feet, or d of 1. Newton realized that this wasn't good enough if we want to get instantaneous speed, because this gave us a 0 on the bottom. He realized we had to let it fall a little bit more time. We had to let it fall a little bit more. So what are the two this new distance, once I get here, is going to be the distance of 1 plus delta t. Okay? And so what he came up with is the average speed is delta d over delta t. Well, delta d is the difference between these two. And if you go back to the previous video, I showed you how to do that. It was 1 plus delta t minus d of 1 over top of delta t. And then I worked through all this with Galileo, because Galileo gave us the distance formula for free-falling objects. So Galileo gave us the distance formula to plug in here. So then this became 16, 1 plus delta t, minus 16 times 1 over delta t. Do you see how much shorter I'm able to do this now? It took me 3 pages to do this with you before. You guys have to redo this proof over and over again, or this concept, until you can do it like this. And see how I'm condensing it, and it means something to you now. Okay? So I'm going down, and then I even worked this out, didn't I? We worked all of this out, and we figured that this was, I gotta look back, 32 plus 16 delta t. Okay, so now Newton says, I forgot what I said. I was so excited. 32 plus 16, okay. Okay, so it's 32 plus 16 delta t. Now, that's beautiful, because this means as I change this delta t, I can get closer and closer and closer to the instantaneous speed when t equals 1 by making delta t small and smaller and smaller. But notice you can never, ever, ever let it be 0. Does this remind you of something, anybody? Making something smaller and smaller and smaller, but never allowing it to be 0? So Newton made the conceptual leap to say instantaneous speed is going to equal the limit as the delta t approaches 0. So the little bit of extra time gets closer and closer and closer to 0, which is 32 plus 16 delta t. He then came along and turned on the limit. Ring-a-ding-a-ding-a-ding. So as delta t approaches 0, that approached 0. And guess what? He found out that the instantaneous speed of that apple falling at t equals 1 was 32 feet per second. And you have just solved a problem from antiquity. That is cool. And to put this in general terms, we can say that the instantaneous speed is equal to the limit as delta t of the average speed, as long as delta t approaches 0. And what that means is the instantaneous speed will be defined as the limit as delta t approaches 0 of, in this case, well, why don't we just do this? And this way it is done in general for any function. And there you go. And that is instantaneous speed. So that takes us to probably I should do so I should probably tell you what I did here. So notice I replaced the 1 for t equals x. So I did it in general now. So this is for any time. Notice I could have done all of this argument. We did it for t equals 1. We could have done it for 2 seconds after the apple had fallen. We could have done it for 3 seconds after the apple had fallen. It wouldn't change anything except this value that I'm putting in here, right? So we'll do a definition here. The instantaneous speed at any time t equals a of an object with a distance formula there you go, with a distance function d of t is denoted by s of a or v of a. So from now on, when we have s of a or v of a, these mean instantaneous. This is not how you spell instantaneous. This is instantaneous speed. And in this course, if ever we mean average speed, we will say average speed. So this is going to be defined as S of A equals the limit as delta t approaches 0 of the distance formula at A plus delta t minus the distance formula at A over top of delta t. Or, in other words, the limit as delta t approaches the difference quotient. Or, in other words, the limit as delta t approaches average velocity. At t equals a. And there you go. So that is a definition of the instantaneous speed. And now we'll do some examples with this. I'll stop the video here and come right back.